So the next topic is induction generator. So generator is nothing but which will take mechanical input and convert it into electrical output. Here we are considering the combination of induction generator. So we have studied about induction motor. In generator usually the slip will be negative. So you know what is slip? It is nothing but it is the difference between synchronous speed and actual speed of the motor expressed as percentage of synchronous speed. Here in this case we are connecting a petrol engine that is coupled with the induction motor. So here this petrol engine acts as a prime mover which gives mechanical input to the induction motor. Here we are having supply lines. The induction motor is connected with the supply lines. In case of generating mode, the speed of the rotor will be greater than synchronous speed. So we normally know what is slip. It is nothing but ns minus n by ns. So in this case, if the speed of the rotor is greater than synchronous speed, automatically the slip will be negative. So the negative slip indicates that power flows from rotor side to the supply lines. So here the induction motor acts as an induction generator, so that instead of it will supply power to the lines. So here the reactive power will be taken from the supply lines. So in this case, induction generator, normally a generator takes mechanical input and converting it into electrical output. What is the principle of induction means? The rotor receives electrical power by induction. So here we are having a petrol engine that acts as the prime mover and it is coupled with the induction motor. So induction motor is connected with the supply lines. So here the slip of the motor is negative. When will you get negative slip? Means the rotor speed is greater than the stator speed or speed of the rotating field. So slip we will get like this. So when the speed of the rotor is more, that is n is greater, at that time the slip will be negative. So the motor acts as a generator. So the rotor speed will be greater than the synchronous speed. So the power flows from load to the supply lines. This is the basic principle behind induction generator. And the another one concept is synchronous induction motor. So synchronous induction motor, what is synchronous speed? The motor which runs at synchronous speed, that is ns equal to 120 f by p, that is called synchronous speed. But induction motor, so it has the features of both synchronous machine as well as induction machine. That's why it is called synchronous induction motor. So it has the features of high starting current, starting torque, constant speed. So these are all the features of synchronous induction motor. So separata we have studied about what is a induction motor as well as what is a synchronous motor. Here in this particular configuration we are combining the features of synchronous machine as well as induction machine. So synchronous motor always runs at constant speed irrespective of load variation. That is a special feature of synchronous machine. Induction machine mainly used for variable speed application, particularly in industrial drives. So most of the variable speed application we are referring induction motor. So here in this synchronous and induction motor, both the features are combined so that we are getting high starting torque as well as constant speed application. So starting torque, it is nothing but the torque developed by the induction motor at the time of starting. So we know what is a torque. It is nothing but the turning or twisting moment. So high starting torque is required initially to start the motor from load variation. That is various to overcome its inertia we require high starting torque. So this synchronous induction motor combines the features of both synchronous machine as well as induction machine. It is very particular important thing in this case of synchronous induction motor. So here we are having supply lines. So here we are having a motor that is nothing but an induction motor. So what is an induction motor? The rotor receives electrical power by induction. normal DC motors and all conduction motors. Here it is induction motor. So the rotor receives electrical power by induction, and we are having two types of rotors. One is squirrel cage rotor and slip ring or wound rotor. Here we are using slip ring or wound rotor because here with the rotor we can add starting resistances, so that the speed control is possible in case of slip ring rotor. Whereas in squirrel cage rotor we are not able to connect the rotor windings, so that speed control is not possible. Whereas in slip ring or wound rotor, the rotor is connected with variable resistances. So that's why we can improve starting torque, speed control is also possible. So here the motor at the time of starting, it is connected with the variable resistances, and here we have a exciter. The exciter is coupled with the motor. So at the time of starting we are connecting variable resistances, so that the induction motor runs as slip ring induction motor, so that it is possible to achieve high starting torque as well as speed control. Once it moves to the run position, when the switch is moved to run position, this machine acts as a synchronous motor. For synchronous motor, DC supply to be provided to the rotor part. So the rotor of the synchronous motor must be supplied with DC supply. So that DC supply is provided with the help of exciter. So exciter, we have two lines, one is directly connected and the other half of the DC supply is given to the exciter. So this is the thing. So when the switch is thrown to the run position, DC supply is provided to the machine. That is slip ring induction motor. So the rotor of the slip ring induction motor is supplied with DC supply. So what happens means permanent magnet fields will be provided. So this machine can be running at the time of starting as a induction motor, whereas at running position it runs as synchronous motor. So it combines both the features of synchronous and induction motor. That's why it is called synchronous induction motor. So we can have some recap. So in synchronous induction motor, it combines the features of synchronous machine as well as induction machine. So here we have supply lines. The induction motor is fed from the three-phase supply lines, and it is provided with the starting resistances. So this acts as a slip ring induction motor, so that we can have speed control at the time of starting. So when the switch is at the time of start position, the resistances are included in the circuit, so that the induction motor runs as a slip ring induction motor. So it provides high starting torque as well as speed control are possible. Once the switch is thrown to the run position, at that time the exciter provides necessary DC supply to the field of the rotor winding, thereby it produces the permanent magnetic field, so that the induction motor runs as a synchronous motor. So it combines both the features of induction motor as well as synchronous motor, thereby we can have high starting torque and constant speed application is possible. So the main advantages of synchronous induction motor means high starting torque as well as constant speed application, we can use it, and the exciter used is not of that much complicated. These are all the main advantages. And drawbacks means here we have some losses due to the inclusion of resistance. So we have some losses occurring, and that is the drawback of this synchronous induction motor.